Okay, so specifically, we're looking at your note sheet, and again, we're going to rely heavily on technology to do most of this work for us, but I do want you to have some idea. And so last time, I guess that would be Monday. What is today? Tuesday? Sure enough. Monday, we looked at how to figure out the correlation coefficient R, and a little bit about that. And now today, we're actually after this second thing here, y hat. Little hat over the top of it. And basically, that's the equation, that's the regression equation, the equation that goes through those lines. And so, again, it's actually kind of amazing. We don't have time in this class to kind of look into that, but it's kind of amazing to think that, you know, somebody found a way to find the perfect equation, and basically this is what that equation is. So notice, and we saw this, well, quickly cheating even yesterday when the calculator gave us values for these two numbers, and your calculator called them A and B, and here it's M and B, but notice here's actually kind of a recipe for how to get them. So what I'd like to do to start with is actually to kind of use this recipe and do this a little bit by hand. So yesterday we found up here the sample standard deviation of X and the sample standard deviation of Y. And notice those two things are used again down here to figure out this M number, the slope, it turns out. So if I take the R value times those two divided, I actually get this number. And then the B can be found, well, using some of the similar numbers. Also, we had the sample mean of X and the sample mean of Y. And so notice those are kind of the ingredients down here. Let's just see if we can kind of pull this off by hand. So I can't show you this in the problem we're about to do. So hopefully you're staring at your note sheet. I'll have to go back and forth a little bit. But let's do that with this problem. That's right, I gotta load it. So again, this process is called regression, finding the equation of a line from a bunch of data. So I'm not giving you a copy of this, but so here's a list of boards. Again, this is kind of related to what I said the other day, lengths and heights. Lengths and weights. And so here's some random data that maybe somebody would have collected about Versalam beams. And so these are the, you know, one of the main ingredients of how a house works. And so what I'd like you to do is put, as we did yesterday, I'd like you to put basically this into list 1 and this into list 2 of your calculator. And we saw a second ago that we needed, let's see, what was it? S of X, and we needed S of Y, sample standard deviation of Y, and we also needed the mean, sample mean of Y and sample mean of X. Like those are the things we needed. So let's get them. Sticking this in our calculator. So list 1, list 2, 12, 24, 31, 44. Should have data in there yesterday. You need to delete 341, enter 690, enter 886, enter 1274. Double check that you didn't type them in wrong, just so that that doesn't leave you distracted. 144, 51, 696. So you may remember yesterday we went to stat and then to two variable. Statistics to produce these. And so see if you don't get the same thing I get here. So second quit, stat, calculate, two variable stats. list 1, list 2. So I got for S of X, you told me if I'm right or wrong here, I got 13.376, I guess. And for S of Y, actually I'll get X bar is 27.75.
You don't want us to round it up to like 13.38.
I don't care. Yeah, if you called it 13.38, great. I don't care about rounding. I just decided to carry it out a little further for some reason. And remember, you can do these by hand. I mean, God forbid, like let's not do that, but you know how to find a standard deviation by hand. You are gonna have to find that by hand on the test on Thursday. So we can do this by hand. And of course, the mean's not terrible, right? X bar. I could have added all those numbers up and divided by 4 and got 27.75. I mean, that wasn't that much trouble. And then let's see, what are the other things I needed? Y bar is 797.75. And the sample standard deviation of Y is 389.37. I guess I'm just going to round to 2 decimal places on this one. So those are kind of the ingredients that we need. And we said yesterday, if we wanted to, actually, and let's steal. So perhaps you practiced this a little bit, but now we could actually do this calculation by hand ourselves if we wanted to. Now that we have all of those ingredients, let's see, what do we got? Yeah, X bar, S of X, Y bar, and S of Y. And so that's quite a process that we went through yesterday, but unless you make me, and I will not be asking you to do this by hand on the test, I want you just to cheat and get it out of your calculator, which is good. But I can do that. So notice down here now we have, let's see, what ingredients do we have? We've made everything we need. We have this, we have that, we have this, we have this. Oh, the only thing we don't have is R. So, and again, I don't really want to work that hard to get that. So let's steal that too from yesterday. Oops. So did you go now to get R? Remember, you're also going to stat. And then to calculate. And then to linear regression. So in a sense, I got everything I needed there. So I'm told that R is, whoa, what does that tell you? 0.999. I don't even know where to round it because it just goes nines forever. If I round the next 9 up, then the whole thing just turns into 1. So even though I should be probably calling this 1, I guess I'll write it out to 4 places. That's okay. What does that tell us about how good of a fit that is? Really good fit. And what does it mean that it's positive versus negative? Yeah. Yeah, it's kind of uphill to the right from your perspective. In other words, and you can see it up here looking at the data, as the lengths get bigger, 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 then the weights also get bigger, bigger, bigger. So that's positive correlation. One gets larger, the other gets larger. And it's really well correlated. So if I were to graph these, those must be really lined up. I mean, so lined up that you probably wouldn't be able to tell they weren't perfectly straight. But according to this R value, they weren't quite perfectly straight. Now, notice in this first question here, I said, use regression function of your calculator to find a linear model for the relationship between X and Y round values to 1 decimal place. Well, again, isn't your calculator telling you what this is right now? So the linear equation is Y, and I'm gonna actually even write Y hat here because that isn't just any old equation, it's the regression equation. And it says 29.108, so 29.11. And then you have to throw the x in there, and then it's plus b, but then b is negative 9 point something. So let's see, what did I say? Round to, I said round the values to 1 decimal place, and then follow my own directions. And that would be 9.99, but then that would round up to 10. So I guess this is minus 10. Are you able to get all of that on your graphic calculator? I only did it once yesterday, so. Now, all of that is entirely sort of cheating. Now, do you agree that if my only goal, as this question really is getting at, is just, hey, find the equation for this, I really don't need all of these ingredients up here. I didn't need those to get what I got, because the calculator was designed just to spit out what I needed, and I got that. So great, I'm done. But just to elaborate a little bit, just because it's kind of fun to think for a second. So notice the m is kind of the number that's in front of x. And that's found by taking r times s of y over s of x. So I'm just going to see, would I get 29 for that? If I did that, that's what. So let's see, m. M is basically this number. And it actually has a meaning. We'll talk about that in just a second. It actually has more of a meaning than just some number that's sitting there. And then it was s of y divided by s of x. Like that's how we could find it by hand if we weren't cheating. So I'm just kind of wondering if I, plug this in myself, would I also get what the calculator just told me, 29.1? So let's see, I just found that r was 0.9999. And we set up above that s of y was 38.389.37 divided by s of x, which is 13.376. So if I type that in my calculator, is like, do I get 29? Is that what's going on inside the calculator, if you will? 389.37 divided by 13.376. Yeah, that's exactly what I got. So I got 29.107. So, okay, cool. That's what's built into your calculator. That's what we didn't really have to pay any attention to. We just got this m value for free over here, if you want, just by using the regression feature of the calculator. Technology is wonderful. And then let's see, this 10 number, what was the recipe for that? So yeah, y bar, the sample mean of the y's, minus that slope we just found, times the sample mean of the x's. That's what I got to do to get b. So supposedly if I plug that in, I'm going to get 10, because that's what the calculator just said. Let's see if that's true too. See, where am I going to squeeze this in? So B, we said, was found by taking y bar minus m times x bar. So that would be 797.75 minus that slope we just found, 29 point, I'll call it 11. multiplied by X bar, which is 27.75. And so the question is, are we going to get minus 10 for that, since supposedly that's what the calculator just gave us a second ago? Again, I think it's worth taking the time to punch this in yourself. And even though these are rather mysterious formulas, yeah, sure enough, I got negative 10.05. Now, for accuracy's sake, does it make sense that I have been rounding all of these numbers off up here? And again, I just want to point this out with respect to my open math, because if it says get the answer right to 2 decimal places, this answer here of negative 10 was correct to 2 decimal places, and yet, is that what I got? I got negative 10.05. My answer is right, but it's not rounded the same. And if I was doing this in my open math and it wanted it accurate to 2 decimal places, I would have gotten it wrong. But that's because of all the rounding I did up here. Does that make sense? So our calculator a second ago didn't round anything, and so the answer was really 10. But I'm close enough that I can see what's going on. Lauren.
I got negative 9.775. So that was a 797.75 minus 29.1.
Got it. I put in 1, So again, that's why I don't want to emphasize rounding. I put in 1, unless I type something in wrong. I typed what I wrote. So yeah, I mean, if you're getting something around 10, it just shows you're doing it right. So I got a little over 10 and you got a little under 10, but we both basically got 10. So the point is, this is what's programmed into your calculator. Isn't that amazing for 2 reasons? One, I don't have to know or memorize these formulas to be able to get what I want to get. And then 2, I don't have to, go to the trouble to plug everything in and even know the algebra to be able to get the answer that I'm after. That's just kind of cool, I think. But as I've said, I think it's kind of neat to understand you could do this by hand if you really wanted to. And as I've said before, this calculator is not that old, maybe 30 years old. People were doing this by hand for, hundreds of years. So it's crazy. We, if you will, get to have the luxury of spending all of our time trying to interpret this stuff instead of just trying to calculate it. So big takeaway here, I got this awesome regression equation. And so y hat is that regression equation. However you get it, ideally cheating. Yeah, so that is the linear equation. That's the line that goes through these points. Now, again, what I want to illustrate with these problems that I'm giving on this sheet is finding the equation is kind of cool and challenging and crazy and so forth. But the more important thing in the real world is to be able to use it for something. So notice, and this is kind of an important thing to do, to use it for something, I have to kind of go back and think about, what were these numbers again? Oh, length was X. And so this is a length right here. That's the length of the board, and the Y was the weight. Okay, so that's what that means. So in other words, if I want to know the weight, this is saying, this recipe is saying, take the length and multiply by this number and subtract 10, and that'll basically give you the weight. That's kind of cool. Again, this is very practical to me because I've framed quite a bit and I've set beams like this for the most part in just residential construction. You can set beams like this just with you and one other person walking up ladders with it on your shoulder. But if I could know ahead of time, oh, that thing weighs 500 pounds. And so it's like, we're not going to be able to do that this time. This is kind of cool. It's practical. So the question is, can you use this for something? So you try to get this before I answer it for you. Use the equation then that you just found to predict the weight of a 52-foot Versalam beam. Can you see that okay? I guess I can zoom in on this part. So you had to order a 52-foot beam because somebody had a big back porch. So you're just wanting to know, hey, is there some way now that I found the relationship, there's surely a relationship between weight and length. Now that you know what that is, exploit it. Use it for something valuable. Use it for something practical. I'm hoping with the algebra that we practiced that you can speak the language of equations. We did this going out the door quickly yesterday too. On the test, my only concern would just be read carefully enough that you know where you're plugging 52 in. It'd be easy to accidentally plug it in for Y, but because it's 52 feet long, because that's feet, and you're being asked for weight, which is Y, so you're being asked for Y and you're being told the length, so it definitely has to go in right there. Okay, that's pretty straightforward order of operations. 29.1 times 52 equals minus 10. So hopefully you got roughly 1,500 pounds. And again, that's kind of like, oh, I'm glad I figured this out because I'm not going to lift that. I'm not going to walk up a ladder with that on my shoulder. So this is going to have to be a crane setting this beam. That is really long. I often, I've got numerous friends who give me a lot of crap, about being a math teacher, like making people suffer for a living. And I totally get that. And I laugh, and then, we laugh about it. But to me, this is what math is really for, because most people say, well, you don't really need math. And that's kind of true. Like you can get through a lot of life without it. But on a job site like this, with that beam delivered, the people that don't think about this stuff or don't have some skill, don't have skills like this, are the ones that, walk over to the beam and everybody's there ready to work. And it's like, oh, geez, we can't lift this thing. And now it's like, now everybody just stands there while they call a truck or something. And, it's like 2 hours later when it comes. And, whereas a person that knows math is going to plan ahead and already knows how much it weighs and ordered the crane to show up yesterday. So when everybody gets to the job, there's a crane there waiting. I mean, those are the people that make more money and then actually get stuff done. And so that's, to me, that's the advantage of it. What about the other way? What about the second question? I'd say less practical in this case. But if you had a beam that weighed 1,000 pounds, 1,048 pounds, could you predict its length? Can you use the equation for something? Of course, the key to start this is to realize that 1,048 you're being told is actually Y, not X, and therefore it's the same equation, but this time you know something different. So we talked quickly yesterday about how if you're solving an equation like this, given that this is the order of operations, because we're trying to unwrap it or work in reverse, then we're actually getting rid of stuff. We're trying to figure out what X is equal to. We're getting rid of stuff in the reverse order. So I'm first looking for adds and subtracts to get rid of. And then second, so check, got rid of add and subtract. Second, I'm looking to see, is there any multiplies and divides? Oh yeah. And then the opposite, of course, of multiplying by 29.1 is dividing by it. So if I divided it over to the other side, then I would finally have what I was after, which is I want to know what X is. Now it's by itself. My calculator will tell me what that is. Got roughly 36 feet. And notice hopefully you're doing this with me. I really got 36.35, but remember, if I'm framing and I'm just trying to, roughly figure out what this is, I don't care about all the decimals. I'm just kind of wondering, how long is this thing? Oh, it's around 36 feet. close enough. My purpose wasn't to be perfect. It was just kind of figure out kind of what's going on here. So I guess I'm interested, I'm interested that you see the concept here that this person only had to gather 4 pieces of data. And because there's a definite, very well-defined relationship there between those two, because the R value said, yeah, it's perfect, like this is a really good match, we now own the relationship between weight and length. And so now we can use it to predict things that we didn't know. And that's what's kind of so cool. So if somebody said, hey, I've got a 24-foot beam, how much does it weigh? Notice I already have the answer to that, 690, but there's a lot more beams up here that I don't have, like, well, 52 feet. 52 feet went off the chart. And so how much is it going to weigh? Well, the fact that I came up with this equation here means I was able to express that relationship in an algebraic way. I mean, that's so cool. I mean, I would say I graduated from U of O with a math degree, didn't understand that. Even though these are really simple equations mathematically, I did not really understand that that's what an equation can actually do, is express a relationship that allows me to get any answer I want. And that's what's kind of so powerful about an equation like this, is I can answer any question of this nature that I'm interested in, and I own them all now. And it's all packed just in this one little statement right here. So I want to say something, I might, let's see, I think I'll go down below. So in the equation, this is typically the way mathematicians write this equation. In this equation of all lines look like this. That M is the slope, and the B is often called the y-intercept. Which really just tells you where the graph crosses the y-axis. So let me show you kind of in this case why knowing that number is the slope is kind of such a neat idea. Because slope is kind of defined as rise over run. So if I had a, kind of a line that looked like that, and I was kind of working from here to here, and I said, okay, that's a rise of 1, 2, 3. So there's a rise of 3, and then a run of 1, 2, 3, 4. So what's kind of powerful that is does it make sense? Rise is going in this direction. This is kind of in the Y direction. And the run is going in this direction. That's kind of in the X direction. Kind of the X, the run. Well, we had units for that a second ago. So let's see our Y value. What was our Y value? That was a weight. So our Y value was in pounds. And our X value was in feet. So that 29.1 we just got a minute ago, it isn't just a number. It actually tells us something kind of neat about the beam if we include it. So it was rise over run. Rise was, as I said, kind of in the Y direction, and run was in the X direction. So if I put units on that, for us, the slope of 29.1, rise over run. Y was pounds, and run X was feet. And so, oh, what's that 29.1 mean? It actually means that's how many pounds per foot the beam actually weighs. And would you agree that 10 pounds, the minus 10, that was a part of this problem, 10 pounds isn't that much when you're talking about well, beams that weigh 1,500 pounds. So roughly speaking, you could just take, even if you just kind of rounded it off, you could say, oh, so beams weigh approximately 29 pounds per foot. If I didn't need to be perfect. So basically now I could say, oh, if it's 50 feet long, I could just multiply by 29, and then I would know approximately how much it weighed. So slope is kind of a cool topic, and it's actually cool enough that the topic of calculus, which I'm sure you've at least heard the word, which is quite a number of levels above what we're studying in terms of difficulty, the entire focus of that is slope. Okay. Let's see. So take a look at these two questions. So how did we get the equation? We got the equation either entirely cheating using the regression button, which was absolutely wonderful. And notice that used all 4 points kind of simultaneously, like we graphed 4 points and we stuck them all in there and so forth. And then we also said, yeah, well, I could kind of get those same values by hand with a little bit more work and so forth. But could you actually, understanding that that's the slope and the y-intercept, could you actually find these equations entirely by hand? The answer to that is, yeah, a little bit you can. Let's see, in the interest of time, we only have 10 more minutes. I think maybe we'll save that discussion for tomorrow's algebra time. I think that's what we'll do. So let's just take a look at a few more examples. Like in a sense, what I just showed you right there is really the essence of what I want you to be able to do on the test, minus this doing it by hand business. Entirely just what this problem originally said was use the regression function of your calculator to find this. Cheat, in other words, cheat. Give me the equation. And because of that, you find the equation really pretty easy, unless you type something in wrong. That's kind of a freebie. And then the important two things are great. Now, can you use it for something? So in terms of prepping for Thursday, really, that's the main thing I want you to be able to get out of this. And of course, it is important to be able to, record the correlation coefficient. So let's do this. So how are you doing at your skill of how are you doing with your skill at kind of graphing this? Let's take a look at what we just did and see if it really works. So I'm going to go into the y equals screen. Now that we think we have this equation, 29.1 x minus 10, and I basically just want to graph those 4 points on the calculator, and I just want to watch the line go through them and kind of go, yeah, that kind of makes sense. Look, I see a correlation that's really high because those points are almost lined up, and so that's kind of cool. Another little nerd trick here. Did you see how the equal sign there is kind of bold and black? Actually, I kind of don't want to graph this just yet, so I'm going to go over there and hit enter, just like the plot up there. And so it actually won't graph now. It's like it's in there, but it won't graph. And then I'm going to do what I did yesterday and cheat and show you, like I want to graph those 4 points, but remember it takes time to locate where they are, like focus the camera on them. So I'm going to say zoom and then go down to stat. In other words, zoom the camera straight at the 4 points we have typed in. And so see how it's like, bam, super quick, and it's aiming right at them. So again, because we saw the correlation coefficient was so high, 99%, I'm not surprised to see those all lined up, but I didn't know those were lined up when I was originally looking at the data. And now I can see they're really lined up. And so of course, if I do go back in and say, yeah, and I graph that line, I can see that I must not have screwed up, because that really does go through the points. And it actually, hits most of them. If not right on, at least really close to right on. Any questions about that? I mean, do you feel like you're making progress with getting the calculator to do that stuff? And how did I get it?
Yeah.
I went back to the y equals screen and typed in the equation that we got a second ago. And in my case, I turned that equal sign back on and said graph it. But again, this x right here is really important. If you leave that off, if you leave this x out right here, it's not going to do too good. So any of that you want to ask me about, one-on-one, I mean, I understand it's kind of awkward. It's kind of hard to ask a question without me coming over there anyway. So let's take a quick look at, and I won't go through all of this, but just enough that you can look at this later if you want to. I just want to show you part of a PowerPoint. So I showed you this part of this the other day, but we just didn't find the equation for it. So again, I got a bunch of data. I stick it in a graph. Oh, look, they look like a line. Notice it's very helpful, as I said yesterday, if you add a bunch of other lines to this, like a piece of graph paper to it, then it becomes really easy to see. And notice there's some values on here that you can totally tell are perfect. Like notice 32 right there, it hits perfectly. And because it hits right where that crosses, I could come over here and actually interpret this. Let's see, it's from 200 to 300 and there's 5 boxes, so they must be worth 20. So I guess that would be 280. So this is 32 feet, 280 pounds. So it's like I can read that off perfectly from this. So what I'll do in class tomorrow is, maybe a little bit right now, is find the equation by hand. So what we've been doing is just cheating, which is way better, but can you pick 2 points that define the line, like really points that really go through it? Notice I said, how about 26 and 220? If you go back to the graph, does it really look like that goes through 26 and 220? Notice the line doesn't really go through any of the black points, the ones that the data came from. Does that make sense? So I didn't want to pick those, but 26 right here, you see how that kind of hits right there? And that would be 220. So the point 20x is 26 and y is 220. It really goes through that. Let's see, and this looks like it goes through that one. The one I mentioned a second ago, 32. What was the other one I picked? The other one was 54, 500. So 54 is right there. Oh yeah, I can see why that looks like that goes through that as well. So we're trying to find a line that goes through those 2 points. Well, a second ago, I mentioned that the m is actually the slope of that line. So the question is, could I count that? In other words, if I took off from here and I went to this point here, how many do I rise? Aren't I rising 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14? Like, isn't there a rise of 14? Except for each box isn't worth 1, right? It's worth 20. So I rose 14 20s. And then, well, maybe I could just do the math here. If I went from 26 all the way down to 54, how far is that? Notice down here, each box is worth 1. So I could actually count the rise and the run just from this picture right here. And does it make sense? I would know the slope. I'm not using all of these formulas. I'm just using my brain. And this is kind of what you would learn in a normal algebra class. But it's kind of cool to note here that because slope is rise, you can just subtract the y values of those 2 points. So in other words, 500 minus 220. And that actually tells you how far you rose. So I counted a second ago and it was 14 boxes. 14 times 20. But you could have just went, well, the y coordinate of this point was 500. And this one was 220. So how far do you move if you go from 220 to 500? If you subtract, doesn't that tell you the answer for what that is? And the same thing would be true for x. If I went from 26 up to 54, I could just go 54 minus 26. And so what is that? 280 divided by 28. 280 divided by 28 is 10. So I got a slope of 10 there, which means, don't I already know the number in front of the x? It's y equals 10x, but I just don't know the other number. But then how could you find that other number? Well, you can find b by plugging in the slope and one of the 2 points, because the line goes through these 2 points. And so therefore, if I put these numbers into the equation, it should work. So I decided, well, when x is 26, y is supposed to be 220. So I put 26 in for x and 220 in for y. And then I was able to figure out b is negative 40. So then, hey, look, I have the equation for the line. Y equals 10x minus 40. And so I was able to do that entirely by hand. I mean, that's kind of neat to understand too. The downside of this, though, is that it's a lot more trouble, it's a lot more work, and you're only considering 2 points. You can only have 2 to do this, whereas regression is easier and it considers all the data. And so that's kind of neat to understand. And then I'm highlighting here something I just told you a minute ago. What do m and b represent in the data beyond slope and y-intercept? This is the same illustration, length and weight. So being able to use this for something, again, now that I have an equation, then I can use it for stuff. How much will a 72-foot length of channel weigh? Oh, I put 72 in, calculate this, and I get 680 pounds. Or another problem like we just did, how long would a length of channel be if it weighed 250 pounds? So since that's a weight, I had to put that in for y and then solve for x, and I can predict that it'd be 29 feet. So, and then just so you can look at this later if you choose to, I would say you don't necessarily need to, but I'm just reiterating kind of what's on your note sheet here a little bit. So this is what your note sheet says. M is found by taking R times SY over S of X, and B is found using this formula. And so you could plug those things in and basically figure this thing out by hand and so forth. So you can play with that. But as I said, you don't have to do that. Notice when you use regression here, a second ago, we got 10x minus 40, but notice when we use this method, we didn't get 10x minus 40, we got 9.95x minus 36.72. This is actually a little bit better because it's considering all the data points, not just the 2 that we chose off the graph. So anyway, we'll play with that a little bit more tomorrow, because of course it's really wonderful just to do regression on your calculator and just let it punch out the answer. All you got to do is put the data in there and out pops the answer. That's so awesome. Okay. 1 hour always goes way too fast. What are we doing tomorrow? Yeah, so tomorrow we're basically I'm gonna show you how to get Excel to do this. So I've showed you how to use your calculator to do regression and how to make a graph and so forth in your calculator. But again, your calculator graph is ugly and not usable. Like I could make a report from it. How do I get it out of the calculator and put it somewhere else? Whereas Excel is much nicer because you can actually label the graph and put, lines across it so people can see it and read it. So, how can I put the same data into Excel and get it to produce the equation and that R value? And again, it's super easy. We don't have to work very hard at it. We just have to know how it works. So we will mess with that tomorrow. And today, if you want to, again, ask me anything test prep related, or maybe there's something in the homework. Again, your homework this week's homework isn't due till Sunday night, but obviously it's not going to do you any good unless you do it unless you get it done before the test on Thursday. So if you have any of those questions, you're welcome to ask those as well. Otherwise, awesome. See you tomorrow. So Hannah asked on the chat about whether I'm going to upload the sheet I was working on about math. Yes, I always am going to do that. And then the review is not for credit. So if there's anything in the review, you're like, oh, I totally get that. Well, then don't do it because it's not an assignment. So it's only there for you to practice if you need it. So no, you're not turning that in.